In this video, we're going to talk about how you revise A-level chemistry. So getting started. Get organised, get a timetable, know your specifications. So people who just revise and go on websites and things like that, there's lots of websites that give you lots of videos, but most of the videos that you watch are not specific to the specification. On Virtual Exam Tutor, they're all specific to the specification. Okay, and that's how you get an A and an A star. Get yourself a timetable. You can see this person here has a timetable written on a very handily used blackboard behind them. Just have a timetable, rough timetable. You won't always achieve everything you want on that timetable, so don't beat yourself up if you don't, but have some organisation. Make sure you have breaks. Don't revise for too long. Revising generally for 30 to 40 minutes is better than doing 3 hours straight. Have a little break, then come back, okay? Just really get organised. After that, arrange with friends who are doing similar subjects to sit with them and work. And you can see this student here working with another student on a problem. Work with your friends. Work with your friends who you think are going to be working to a similar level to you. And I don't mean that in terms of the actual grade they're going to get. I mean that in terms of the effort they're going to put in. You want people around you who are going to try hard, okay, and help you. Now we're going to talk all the way through about active versus passive revision. Passive revision is what you're doing right now. So you are watching this video and you're not doing anything whilst you're doing it. You're not using the information, you're not converting the information, you're not transforming the information I'm giving you. So I'm going to stop you right there and hopefully tell you to do something during this video. So I want you to write some notes. Maybe think about which ones you'd like to do. Ones I mean what techniques you'd like to do, which ones might suit you. Write those down. Write something down while you're doing it. Turn this from a passive watching of a video to an active. And again, in Virtual Exam Tutor videos, you will have past paper questions that have been past paper style questions that are on there for you to do. And there'll be questions during the video, so you can stop the video, do the question, and then watch the explanation afterwards, making it more active. Now, how else can I make my revision active? I'm going to show you something called Bloom's taxonomy. So Bloom's taxonomy is about how you learn and how the teachers teach you. Essentially, they want you to have some knowledge and some understanding at the start, and then they want you to apply that understanding and apply that knowledge and analyse the information that you're given, maybe synthesise some information, create some information of some sort, and maybe evaluate some information. Now, if you want to revise, you want to try and use those 4 core skills at the top. Okay, of course, you've got to know the information, but if you apply the information more, you will know the information more. And we'll go through lots of techniques about how you first get that knowledge and understanding, and then how you practice applying it, which will get you, again, the really high A and A star grades. So throughout the video, we are going to convert, transform, and apply the information and give you techniques to do so. First thing is, a very obvious tool is a mind map. Lots of people use mind maps, but we're going to say how you use a mind map. So a mind map, if you're not sure, is basically taking a central core idea, for example acids, and then going into your textbook, your notes, or any other form of medium such as the internet and things like that, and just writing down the information. I would recommend, if you're doing a mind map, use the specification as well. Know which parts you need to know. So we've got a simple one on acids here, just as an example. And let's just say I wanted to make this more memorable. Well, I'm going to do something memorable with colours. So acids go red, orange, and yellow in universal indicator. So that makes this more obvious to me. It makes it more memorable because I've coloured it in. And there are lots of colours in chemistry which you can use and do in this way. Loads and loads. Let's just say I do the mind map and I realise that the acids I've put down, I didn't actually remember those. I didn't know those. And you can do this with any information. Well, why don't you emphasise that, embolden that, put that in a different colour? You don't have to do that with everything. Do it with the things you know are difficult, or know that you don't understand, or know that you don't remember. Okay. A better way of doing some revision, though, is concept maps. Concept map is when you connect key terms in sentences and you do it in a visual way. So let's just do a simple concept map. These are very difficult to do, by the way. A lot of people don't do them because they are difficult to do, but because it's difficult, it's actually really useful. So if we do a concept map on metallic bonding, so we've got metallic in the center, just like we have a mind map, and then we put some keywords that we find from our specification. For example, as a regular lattice, and it's a regular lattice of ions and delocalized electrons. We know it's got a high melting point and it's electrostatic attraction. And then we put a few words to connect, like charge density and increase. Now we're going to start to connect them together. So let's put an arrow to regular and then make it into a sentence. Metallic have a regular, and then we put arrangement of positive ions in a lattice. And we're starting to make this into sentences. And then we see and delocalized electrons. And you can see here, if you follow the arrow, you can get a sentence. So increased delocalized electrons and charge density results in a high melting point and increased electrostatic attraction. And then that goes back to the start between regular arrangement, positive ions, and delocalized electrons. So you can see, you can read this. A concept map can be read, and therefore it takes a bit more skill to do it. It's a bit harder to do it, okay, and therefore it's a bit more worthwhile as well. So I'd encourage you, have a go. Maybe stop the video now. Make a small one. It doesn't even have to be on chemistry to start off with. It can be on anything. Just get used to the process and then you can apply it to your chemistry revision. Now, note-taking is something that a lot of people just don't talk about. And especially when you go to university, you're going to need to take notes. Okay, you're going to go to lectures and you're going to need to take notes. And it's really important that you can make notes that are useful to you, that allow you to learn. Okay, so here's our tips for if you are going to take notes, what you do. Now learn to condense your notes using key terms and the minimum number of words. So for example, when I was at university, I would condense all of my notes into about 2 to 3 sides of A4. Okay, and one of the ways in which I did that is when I was given an example, I didn't just copy, I made up my own. Okay, and that sounds really difficult, but it's not as difficult as it sounds. So let's go through an example. If I'm doing notes, condensing my notes in the smallest amount of words, using the minimum amount of key terms, okay, I'm cutting out all of the extra words that I don't need, and that means I'm converting the information. So if we look at an example here, enthalpy change of formation means the enthalpy change which occurs when 1 mole of a compound forms from its constituent elements. That's a required definition in chemistry. Well, I'm going to shorten that. I'm going to find some way of shortening it. So I'm going to take out a lot of the words. Okay, but I know the important words are 1 mole and constituent elements. So I'm just going to put the symbol, delta FH, put 1 mole of product, constituent elements. And that means when I look back at my notes, I'm going, well, what does that mean? I have to think about what that means. And so I look at it and go, oh, well, that means enthalpy change of formation is when 1 mole of the product or the compound is formed from its constituent elements. So I'm shortening it, but I'm making my brain work. And because I'm making my brain work, it helps. Now, as well as that, why not do an example where possible? So here you can see there's an example of making magnesium nitrate. Okay, so magnesium nitrate is your example, but you can do any example. It doesn't have to be magnesium nitrate. It can be calcium oxide, it can be carbon dioxide, it can be anything you want. Just pick a chemical or a compound and just make up your own example. Now that's enthalpy change of formation, but you can do it in so many different other ways. Okay, so explore it and use your imagination. So let's talk about note-taking and diagrams. Now, hopefully you can see from the right here, this is a reflux condenser and reflux setup. Okay, and we have the water going in at the bottom, out at the top. Now, we're going to do an oxidation reaction. The oxidation reaction colour change is, again, here's a link from when we did earlier. We're doing a colour, so we're using the colour. So this is potassium dichromate oxidizing an alcohol. And when it oxidizes an alcohol, it goes from orange to green. So this is a picture of the setup. But how can we make the picture of the setup into something much more worthy in terms of revision? So first of all, I need to make notes of the diagrams that I need to reproduce and for what reactions. But then I use any compound to do this, not the one in your notes from the class or the book, something you've made up. Okay, chemistry is like that. You can just make up different molecules, and it's much better and helps you learn. So let's bring that over here, and then let's start doing it. And again, this is written out by myself. Again, it's just like I'm writing out notes. So what can I write about this reaction? I know I'm going to put butan-2-ol in, and it's going to make butan-2O. First of all, what type of reaction is it? I could write that down. Oh, it's oxidation. I could then say, okay, what functional groups? There's always question about functional groups in exams. So what functional groups are there? Well, that's an alcohol, okay, and that's a ketone. After that, I might draw the skeletal formula, because you have to do skeletal formula within your exams. So let's practice doing that. There's my skeletal formula. Okay, what else do I have to do in exams? I have to do bond angles. Well, let's say what the bond angle is. Well, the bond angle is 104.5. That is not non-linear or bent. And I can do the same for the ketone. So here's my skeletal formula of the ketone, and here's my bond angle. But again, you make this up, and you can practice in anything you want. Okay, and that will help you. And you can have your specification by you and say, well, have I done every single angle? Have I done every single example of every single one? Let's finish off. There's a tetrahedral one, 109.5. Okay, and let's just do our finish off on our colour change again. So again, I'm using colours, orange to green. So we've condensed our notes. We've talked about examples in diagrams and how you can use any example you want, using the specification as a guide. Now we're going to talk about note-taking with flashcards. Now this has been used by people for a very, very long time. So flashcards was the way I learned when I did my A-levels. Okay, and you can see that this flashcard, okay, written by himself, okay, normal flashcard, I've just taken a reaction. On one side of the reaction, I've put the reaction and a general example of the reaction, and then I've said, what's the electrophile, what's the mechanism, what's the catalyst for 2-methyl-propanol chloride. So I've said, there's 2-methyl-propanol chloride. What would I do for these three things? What is the equation for the electrophile, what's the mechanism, what's the catalyst? Now on the other side, I've done those, okay? And so what you do is you try and make some notes on one side with some questions and their answers on the other side. Okay? Once you've got the answer on the other side, flip it over and test yourself. Okay? And that is the way you use flashcards. Okay? You can test yourself or test your friends with them. Okay? Now, there are numerous websites that offer this for free. Okay, so use go on the websites, use them for free. Quizalize, for example, does this, and just make sure again it is on your specification. Let's now talk about revision guides. Bear in mind, a revision guide will not take you up to A star mostly. They're usually condensed form of the information that you need, and they don't go up to the higher questions or the biggest mixture of questions that you can face. Okay, but they are still necessary, and they are very important because they can get you to the information you need very, very quickly. But if you're going to use a revision guide, this is how you should use it. Use it with a workbook. Okay, so these are two examples of revision guides, and obviously there are others. Okay, but these two revision guides come with questions, and they come with an exam practice and workbook. So if you're going to use revision guides, which you should, okay, use both. Do not just use one. The art of doing questions is incredibly important and makes the revision guide much more usable. Now videos. We had to talk about videos because this is what we're doing right now. Okay. Now, watch a video with questions to complete. If you're going to go across videos, and there's many of them, okay, of course I would say go to the videos in the Virtual Exam Tutor website, because the Virtual Exam Tutor website will have exam-style questions and answers explained within the video, as well as the overall topics. You can stop the video where you want, do the question, and then watch the explanation afterwards. Okay, and there are little thumbnails all the way through the videos, so you can cut straight to the information that you want. So if you know you don't know a certain area of that topic, you can cut straight to where you need to go, and then you can practice with the questions within the video, but you can also practice with the worksheet that is with the video. So the accompanying worksheet is there and is very, very exam orientated in the style of the questions that you ask, and is designed to get you to the highest possible grade. There are worked explanations as well with the worksheet. Okay, so that's the best way to use videos. Again, we talked about active versus passive learning. This is all designed to turn your learning into an active process and not just a passive one. So exam questions. When it comes to exam questions, they're split into level of response or short answer questions in chemistry. Okay, we also have MCQs, but do them more than once and use the review method. So we're going to go over the review method shortly. Okay, now read the mark scheme, see if you understand, and also do the multiple choice questions and do them repeatedly, so do them more than once. Make sure you understand them and ask a teacher if you don't. Multiple choice questions on exam papers do not come with explanations, they just come with the answer. Do not settle for the answer, find out why it was the way it was, get it explained by your teacher. Don't just mark them right or wrong. We're now going to go through the review method to answer questions. So you can do this using Post-it notes or OneNote. I'm going to show an example in OneNote whilst I talk you through it. Now, what you actually do is you take an exam paper and you take a question. You then, either with a Post-it note or online using OneNote, is you answer that question. So you'll put your answer on the Post-it note, or you'll do it in OneNote like I am doing right now. Once you've done your answer, you will store that answer somewhere else. So if it's a Post-it note, for example, you'll just put it into a pile somewhere in your notes. Okay, if it's OneNote, what you can do is you can take all of it and then select it and then move it over to the side so that you can't see it. Okay, but if you're doing it in a note-taking software, you can do it in any note-taking software whatsoever. Now, if you look at this one, this is about some intermolecular forces. So I've taken an exam question, okay, and I've written in red, and I've said that the compound A has a lower melting point as it's branched. So you can look at compound A and you can see it's branched. You can see they're both isomers, but this one is branched. Because it's branched, I'm thinking that it has a less surface interaction between the atoms. That's what I've written. Now, because it's got less surface interaction between the atoms, I've then looked at the London dispersion forces, and I've said that those are weaker between the molecules, and then I've gone to look at the energy. So I've said less energy is actually required to break those forces. Okay, so I've got three parts to my question. Okay, something to do with the branching and the surface interaction. And then you look at the green, you can see the green is the question that I did earlier. So I did the question earlier at another time, okay, and now I'm comparing the two with the mark scheme. So I've chopped out the mark scheme, I've put it over there. So I'm highlighting the fact I've put branch there. Oh, that's in the mark scheme. Okay, fewer points of contact. Okay, and I've noticed that I've put surface contact with that one, surface interaction, but they're both absolutely fine. Okay, but then I notice the London dispersion forces. I think that's fine as well. Okay, but I also notice the fact that I have done atoms here. So I've done atoms, whereas on the mark scheme it says molecules. So on one of my answers I've put molecules, and one of them I put atoms. So that's clearly an area which I need to highlight. So I've said I need to say molecules in my notes. Now you can do that review method as many times as you want. Okay, it's a way of getting similar questions done properly, because chemistry does have a lot of similar questions in it, especially when it comes to branching, melting points and such and so forth. Now we're going to talk about some examples that go well with both physical and organic chemistry. Half of chemistry is roughly physical and half is roughly organic. And we'll talk through some examples of how to do that. First of all, do some exam questions, whether using the review method, for example, or just normally. Do as many as you can, keep it the right specification, as I've said. Write your own questions where possible. Use exam questions as a basis, and then use different numbers. And I'll give you an example of this. We've got a titration here, titration question. A solution of sodium hydroxide was added to 25 centimetres cubed, and I've highlighted 1.5 and 21.5 because they're the numbers that I'm going to change. So I saw this in an exam, I copied the question, and I just changed a couple of numbers. And then I'm going to try the question again and do it with those numbers. Now, this student here at my college went way beyond that, and he actually sourced a load of questions from elsewhere. Then he asked me about those questions and said, are these applied to our exam board, our specification? He did a huge amount of work, and he's doing extremely well and done extremely well as a result. So making up your own questions, making your exam questions is good in both physical and organic chemistry, but when it comes to physical, it's easier just to change the numbers. We're now going to summarise all of the techniques that you might use for physical and organic chemistry. Now, first of all, we talked about flashcards. We know that you can put equations on them, you can put questions and answers that you have made up. You know you can make up those questions for organic with a different starting material each time, much like you did in the diagrams that we were doing. And you can use the map of reactions in your textbook. For physical, you can change numbers and examples for those calculations. Now, these are really good for information that needs memorising, equations, reagents, mechanisms as such. Okay, but we're going to describe a slightly different technique, and these techniques are a way of having boxes. So you can have boxes in your room, okay, and you can have a confidence box essentially. So if you're really confident, it'll be number 1, less confident number 2, even less confident number 3. So any card that you're not confident in the content that's on that card goes in number 3. If you're really confident, it will go in your confidence box number 1. Okay. Now all that means is when you do the card and you answer the question, you know that you struggled to get that right, you put it in your less confident one, and then you'll do that one more often. So your less confident box is the one you do more often, the one you practice more often. If you're confident in it, you do it less often. Okay, and that's how you use those different boxes to organise your cards. And we talked about mind maps and concept maps. Okay, and they're really good for written sections that make you explain, such as the ones we've listed right here. Okay, there are many more examples of where mind maps and concept maps will work. You just need to explore your specification and find out. Now, synthesis is an example we're going to go over in the next slide. Okay, and lastly, the review method works for both. So it works for physical and organic chemistry. So I would recommend that you use the review method quite regularly, and you make sure you do as many exam questions in the end as possible. But let's talk about the synthesis example that I talked about. This is really good for organic chemistry revision, and I use it in all my classes, and a lot of the students do tend to enjoy it. So what you do is you pick a starting point and give all the mechanisms and equations and any other relevant information, for example, like the name of the reaction, whether it's nucleophilic addition, nucleophilic substitution, etc., etc. You put all the information down for that synthesis. Now remember, you're picking the starting point, and therefore you're picking the end point. Now, you'll have no more than 2 to 3 steps in the exam, but feel free to make it larger. So you can see on this one, I have taken ethene, turned it into dichloroethane, turned that into dihydroxyethane or ethane 1,2-diol. So I could do the names of these, I could do the bond angles on these, I could do the mechanism, and as you can see, I've done the mechanism right here. Okay, so I've done the mechanism here. I can't fit everything I would like to do on this screen. Okay, so basically, when you're doing it, do as much as you can. So title of the mechanism or description of the mechanism, name of the reaction, mechanism itself. You can have in certain other things like electrophilic addition, you can have how to produce the electrophile. You can have a catalyst equation. So make sure you do everything on them. And if you do something of 2-3 steps, good, because you'll have 2-3 steps in the exam if you're asked to do it. But why stop at 2-3 steps? Okay, so this student did a 10-step synthesis. So he's doing it on OneNote at the moment. That's 10 steps. That's really quite impressive, 10 steps. If you can do that, you'll be really fully prepared, okay? But your ambition is your own limit. So the actual record, in my classes anyway, is 18. And the more you do, the better you get. Okay, if you've got any questions, ask your teacher. Get them to have a look at synthesis. Maybe get them to make a synthesis for you. Test you. They're really, really good for you doing organic chemistry. And just remember, the record is 18 steps. And if you do more than 18 steps, okay, I'm very, very impressed. So let's finish off. A summary is choose which techniques suit you. Do it active, not passive. Challenge yourself wherever possible. Write your own questions. Okay, ask your teacher all the time. Get their help. Be specification specific the entire time. You want an AA star, be specification specific. Okay? And most importantly, if you vary it and use different areas and different ways to engage your memory, okay, and you test yourself on a regular basis, you will be on the way to getting an AA star and having really good revision techniques to take you into undergraduate study.